coefficient of restitution is the ratio of the magnitude of the impulses for the period of deformation to the period of restitution. In other words, the coefficient of restitution is the ratio of the relative speed after the collision to the relative speed before. The coefficient is between the values of 0, completely inelastic, and 1, perfectly elastic. In a perfectly elastic collision, no energy is lost. On the other hand, in an inelastic impact, the bodies stick together after the collision and move with a common velocity. The coefficient of restitution largely depends on the material of the two colliding bodies, but also depends on the impact velocity, shape, and size of the bodies involved in the collision. The coefficient of restitution is useful in the real world because the value can help describe elasticity and therefore the movement of objects before and after collisions. For example, the coefficient of restitution can help describe how to safely and effectively deploy airbags. In this experiment, we are bouncing a ball onto a plate to find the coefficient of restitution, so the formula simplifies to the expression shown, since there is only one body in motion. To find the coefficient, we dropped the ball and measured the heights to which it returned. The goal of the experiment is to find the combination of ball and plate with the highest coefficient of restitution. Since the coefficient of restitution is calculated using a ratio between the bounce height and the initial height, it is logical to expect that the material with the most elasticity will be able to achieve the highest bounce height. As a result, materials like nylon would be ideal for this experiment. For the plate, materials that are stiff and collect a lot of energy are ideal. This would allow the energy from the impact to be transmitted to the resulting bounce rather than be absorbed by the plate. In this case, we decided to select acrylic. There are a couple errors that occurred during this experiment. Slow motion capture of each drop revealed that the ball was accidentally given additional velocity in a couple of trials, both vertical and horizontal, although in theory, horizontal velocity should not affect rebound height. However, accidental spin could have also skewed results. In addition, the method of data capture itself, a 240 frames per second slow motion video capture, is prone to error. Also, aspect differences between the lens, measuring ruler, and location of the ball make it difficult to take an accurate reading of how high the ball rebounded.